Chapter 9. Support Vector Machines. Introduction. Support vector machines, SVM, is a powerful classification approach that extends the concept of the maximal margin classifier. By finding the hyperplane with the largest margin, SVM can achieve better generalization and robustness to individual observations. SVM is primarily used for binary classification, but there are extensions for multi-class classification. It has close connections with other statistical methods, such as logistic regression. Learning objectives. By the end of this chapter, you should be able to 1. Understand the concept of the maximal margin classifier and its limitations. 2. Explain the construction of the maximal margin classifier and the optimization problem involved. 3. Describe the support vector classifier and its advantages over the maximal margin classifier. 4. Apply SVM to real-world classification problems. Key points. The maximal margin classifier aims to find the hyperplane that has the farthest minimum distance to the training observations, known as the maximal margin hyperplane. The test observations are classified based on which side of the maximal margin hyperplane they lie in. The support vector classifier allows for misclassification of some training observations to achieve a larger margin and better generalization. The support vector classifier is the solution to an optimization problem that involves finding the hyperplane and the margin. Real-world application. One real-world application of SVM is in the field of image recognition. SVM can be used to classify images into different categories, such as identifying whether an image contains a cat or a dog. By training the SVM on a large dataset of labeled images, it can learn to distinguish between different objects and accurately classify new images. Conclusion. Support vector machines, SVM, is a powerful classification approach that extends the concept of the maximal margin classifier. By finding the hyperplane with the largest margin, SVM can achieve better generalization and robustness to individual observations. The support vector classifier allows for misclassification of some training observations, leading to a larger margin and improved classification performance. SVM has various applications, including image recognition, where it can accurately classify images into different categories. By understanding the concepts and techniques of SVM, you can apply this powerful tool to solve real-world classification problems.